time to go home because it's very cold now. It's getting very cold. All the ducks and the geese have to go home. This is Salt Lake. It's cold. I have to wear a jacket. Temperature now is 32 degrees. When you revisit Boyles Law, look at the entire engine or the entire design or the philosophy of running a truck or designing an aeroplane, you discover a very central idea that you design an engine first thing. The engine has very thick metal wall and have compartments, we call them cylinders, and you inject the fuel in them in these tubes, and you have electric heater or some sort of ignition system. This is diesel. It doesn't have a spark plugs. Once you heat the diesel with a compressed air, you create ignition inside or combustion. The ignition creates very high pressure gases that moves the pistons and drives the truck. Look at the central idea here is that that engine is the heart of the truck. From the engine you are going to make, the engine is the main compressor in the truck that compresses the pistons to move the truck. Starting from number one here, this is the air compressor that's attached to the engine mechanically by a gear, pinion and shaft. If you look at it from the side, you see the hoses, the lines that inlet, outlet air lines. So it takes the air from outside, from the top, and it compresses it to 125 psi. This is number one. It is driven by the engine. So that compressor simply takes its torque from the engine. Here you have the water pump. The water pump is driven by a belt. That is the belt of the water pump. The water pump is a compressor. It circulates the coolant. Then you have another belt that runs the fan that cools the radiator. The fan is a compressor that circulates air to cool the radiator. So on this side only you have 3 compressors. I think you have more than 3 compressors. You have also, that is the air compressor. I don't know what that unit is. Maybe the fuel, maybe the oil pump. It's a sort of compressor. It drives its torque from the engine. And you have the water pump. Look at the other side. From the top, you have a compressor. This is the cooling system that compresses the refrigerating material. Has an inlet and outlet. Under it, you have the alternator. The alternator is a sort of compressor. The reason it is a compressor because you have the alternator requires torque. It takes it from the engine by a belt. The torque have to cut the magnetic force to generate electric current. So the alternator is a compressor. The air compressor of the refrigerating material is a compressor. The fan is a compressor. The water pump is a compressor. So all these compressors are taking their torque energy from the main compressor, that is the engine. That is the heart of the truck. The same situation in an aeroplane. When you have an aeroplane, every engine is like a heart of the aeroplane. an aeroplane that has two engines does not have the same redundancy like an aeroplane that have four engines. A Boeing 747 have four engines. If you lose three, you can still bring the aeroplane to the ground with a single engine. So the more engines you got, the more redundancy you got, because you can have a lot of compressors. Abundance of compressed air, abundance of cooling, abundance of lubrication. An engine is a heart. Imagine you have four hearts. It's better than having one heart. Here you have an aeroplane landing every few minutes. This guy is too far from us. That's why he looks too far. This is now almost the dusk time. It looks very pretty when he comes down to the airport. I don't know how many engines he got, but my guess he has at a minimum of two jet engines, because he's going too fast and too quiet. Minimum of two engines, if not four. So you ask yourself, why Boyle's Law explains everything? The concept of Boyle's Law is very simple. It is based on what we call it Euler's equation of fluids. So Boyle's Law is mostly a dimensional, simplified law that says the pressure of the gas times the volume of the gas is proportional to the temperature, absolute temperature, by some constant. We call it the gas constant, and that is the absolute temperature. You ask yourself, how did he come up with this idea? Well, he did not come up with the idea. The idea was very simple. When you study physics, imagine you have number of molecules next to each other. We have only here four molecules. The air or the material have trillions and the trillions and the trillions of molecules. If these molecules are, the distance between the molecules would determine the volume. So if the volume is large, these molecules will have a lot of space to knock each other, which means if that volume is large, the pressure has to be small, because imagine four people in a football field. The four people will have a lot of place to run around. If you put the same four people in a single room, the pressure will be high because they will be knocking each other. That is the first concept of the volume and the pressure. Why did you multiply them with each other? Because they are mutual variable. Mutual, which means if one increases, the other decreases. If one decreases, the other increases. They affect each other in a mutual manner. If you look carefully at that equation, if you multiply the pressure times the surface area times the length, that would be the force. Pressure times the area is a force. Times the length, that will be the energy. In other way, this side, the pressure times the volume, is units of energy. Because of that, you find that this is the dimensional logic. You find that if you multiply the pressure of the gas times the volume of the gas will be proportional to the absolute temperature of the gas. And the concept of the temperature, nobody ever explained what is temperature. You try to find any meaning of temperature, you will not be able to find it. So Boltzmann came up with the idea that the temperature, absolute temperature, if you multiply it by a constant, we call it Boltzmann constant, it will give you the energy of the molecules. So now in this equation you have a very simple three variables: the pressure of the gas, the volume of the gas, and the absolute temperature of the gas, and some constant of physics. The volume itself, if you reverse it, if you say 1 over the volume, that will be the density of the gas. So the same equation, you can say the pressure of the gas divided by the density of the gas equals to RT, the temperature. You ask yourself, why did the molecules have to knock each other to create pressure? That is a very fundamental question, because the reason that gases and anything has pressure is because the electrostatic repulsion forces between the electrons. You say, well, atoms are neutral. The protons are positive and the electrons are negative. The problem with that electrons are lighter and faster, and they express the atom more than the protons. So the electrons repulsion is what causes the pressure. That's simple concept, that if the molecules are away from each other, the volume will increase, the pressure will decrease. If you squeeze them in a tight place, the volume will decrease, the pressure will increase. You apply that in real life. This is real life. How do you get from Boyle's law to Pascal's law to Bernoulli's law? We mentioned that before. We said Boyle's law is the same as Pascal's law. This is Boyle's law. And the Pascal's law is no different. You express the pressure, you multiply it by the surface area, it equals the force. This is Pascal's law. And Bernoulli's law, you take Boyle's law, the pressure divided by the density, and you replace the temperature and the constant by V square, which is the velocity of the molecules, of the particles of the gas. We call that Bernoulli's law. That equals the constant. Well, the plus or minus and the equal and the constant, that can confuse anybody. This is a matter of algebra. But the simple logic here is that to create pressure, you have to have force. To create force, you have to have energy. And the force have to squeeze the matter to change the volume. And when you change the volume, you change the temperature. When you squeeze an orange in your hand, the pressure inside the orange will increase, and the liquid juice will be sprayed out in your face. And the temperature will increase inside the orange because you squeeze it, you reduce the volume. That is the pressure, volume, and the temperature and the force. So that equation, the algebra of the equation, should not distract you. The only thing here that anybody who doesn't have anything to do with mathematics, you have to understand that to create pressure, you require force. To create force, you require energy. Energy, we say it V square over 2. 2 is the average and the V is the velocity of the molecules. And you don't have to think very hard about the V square over 2. You just say energy. This is energy. And whenever you have force, you are going to change the volume that you are squeezing. From that 4 variables, the pressure, the force, the kinetic energy, and the volume or the density of the material, you design practical engines. To design an engine, first, in the first compressor that you have the engine, you need to fix the volume. So you make it stainless steel wall that keep the energy firm, hard. Then now you fix it the volume. You can increase the pressure inside. You direct the pressure in a certain direction. You can run the pistons. So what happened to the temperature? You use a water pump. This is your water pump. And you use a radiator and a fan to cool the system. So you get rid of the heat. That is the furnace to compressor. Practical idea, you fixed the volume and you changed the temperature by the radiator and you use the pressure to create force. Let's go to the next system, the air compressor. That is the air compressor that is used in the braking system. He said, okay, what happened to the temperature of the compressor? The compressor is attached to the engine and the engine is cooled by the radiator. So you fixed the temperature in the air compressor. You make it fixed. And you used these hoses, these air lines. If you look at carefully, each airline have a different thickness. The thicker, the more force, because the same constant pressure. You multiply the pressure by the area, cross-section area, give you the force. That is the highest force. That is next to it. That is the smallest force. So the thinner the diameter, the hose, the little the force. The bigger the diameter, the more force you have. If you look at here, this is a distributor. From the distributor, you have two main lines, red and green. The red is for the brakes, the emergency brake, and the green for the surface brakes. All the small lines are signal lines that are if you look at the top here, this comes from the driver's cabin, that where the driver controls the truck by his feet. Those are signal lines. They have little force. All these hoses have the same pressure, air pressure, but all of them, each of them have a different force according to this equation, the pressure times the cross-section equal force. So we treated now the air compressor in terms of Boyle's law. The temperature is constant, the volume is constant because you have fixed tubes and you're using the compressor to transmit force to the remote parts of the truck. You're using the engine to transmit force to the pistons to run the drive shaft. You're using the water pump that takes its torque from the engine to circulate or to compress the coolant. The coolant comes from the top of the engine hot, it goes to the radiator, it comes down from the bottom, it goes to the water pump. The water pump takes it's like a compressor, a fan, taking the torque from the engine. What is the water pump has to do with Boyle's law? It is water. Because it is water, the volume is constant. You only deal with the pressure. The pressure times the cross section equals the force. The kinetic energy here is not important because you are not having a lot of change in volume. The volume is constant. That is the water pump. Go to the next compressor, that is the fan. The fan takes its torque from the engine by a belt. When the fan spins, you go to this equation of Boyle's law. You can choose any equation. You can go to this equation. When the velocity of the fan increases, the pressure has to drop. When the pressure drops, you create a vacuum here and you force the air from the front to go faster through the radiator. That is how the fan is used to cool the radiator. You're playing with the four variables: the pressure, the force, the velocity, and the volume. You go to the other side. Say, why is the cooling system compressor has to do with Boyle's law? And the cooling system you're using Boyle's law simply to reduce the temperature. You get the air from inside the truck through this hose. You suck the air by the compressor, you compress the air to the radiator, you remove the heat in the radiator, you get it from inside the truck. How does it cool? It cools by creating vacuum inside the truck and high pressure in the radiator. So you get rid of the heat in the radiator and you circulate your coolant. If you look at it carefully, the Freon comes in this hose. The Freon goes, it starts from here. Here is the refrigerating system, goes to the radiator, it comes back in this hose, it goes through the condenser. From the condenser, it bends back, it goes back to here to the cabin, the cooling system of the truck. So this is the outlet from the cabin, is the thicker hose, and this is the inlet to the cabin is the thinner hose. The thicker means the volume is high, the pressure is low. The smaller means the volume is low, the pressure is high. So you have high pressure going this way, low pressure going this way. You create inside, you're rushing inside the Freon cooled, and once it goes inside in the vacuum, it expands, it cools the truck. You go back to the alternator. The alternator is a funny thing because you don't have gases in the alternator, but you have the same concept. You have to have velocity, you have to spin the alternator. It cuts the magnetic field by force. So you have the velocity and the force, and you do create pressure, electron pressure, which we call it electric current. That is the whole concept of Boyle's law when it comes to the atomic nature of the law. How the people of physics think about Boyle's law when they explain to you the stuff, the four variables. You will ask yourself, if every engine in the planet have to use Boyle's law, to use gases to exert force, to produce force, that airplane that's coming now from in the skies have to use kerosene or petroleum to run the jet engine, and the jet engine have to go very fast to create enormous pressure. Enormous pressure creates a force that keeps that aeroplane flying in the sky. So you ask yourself, how do here is a man walking in that truck. How do humans are machines, organic machines, yes. But how do humans function without air compressor? That will take you to the very basic question of the electrostatic charge. The humans follow the same law on a microscopic level. You do get hot, warm when you work out, and you can sweat, which is a radiating system. Your radiator is your skin, and your compressor is your heart. And the heart circulates the oxygen and the carbon dioxide in the body. That's how you live. So you are a machine. You are a machine using air, oxygen, and carbon dioxide, and using a pump, that is the heart, and using the skin like a radiator. So where does the combustion happen in the body? It happens in the mitochondria, inside the cells. The cells of the mitochondria in each cell in the body takes the hydrogen, mix it with oxygen, remove the energy from it, so you don't get burned with the explosion, with the combustion of hydrogen and oxygen. But you get warm. When you get fever, which means you are sick, means the mitochondria is damaged with a virus, bacterial, or any kind of sickness. But you follow the same law of physics, that you require gases to generate force. How do you go to the moon or the outer planets? Whether you're using hydrogen and oxygen to propel a rocket, you are generating gases. If you're using solid fuel, you have to convert them into gases. The solid fuel have to burn like gases. The solid fuel is very fast, so you use it for certain purpose. When you have very steep acceleration, you use solid fuel rods. But you have to convert into gases, which means you have to follow Boyle's law. So we did solve the problem of the organic machines, that's humans, animals, that have to follow the same law of electrostatic repulsion that creates pressure, and the pressure creates force, and the force requires energy, and the force changes volume, and the change of volume changes matter. Go to the last two questions that everybody asks. Why is electric car doesn't follow Boyle's law? It does, it have to, because where do you get electricity? You have to charge it from the outlet. The outlet have to bring electricity from power station. Power stations use boilers, because you have to run a diesel engine in a power station. The diesel engine runs the generator, and the diesel engine have to follow Boyle's law, the same like a truck. If you use nuclear power, like a nuclear power station, you have to follow Boyle's law. How do you get heat from uranium from a nuclear reactor? You have to use water or any coolant, and the water have to evaporate at very high pressure. The water will create steam, and the steam will run the steam turbines. The steam turbines will drive the generator, electric generator, you get electricity. So any way you look at it, Boyle's law simply means how to exploit the electrostatic charge of nature that is in the matter to generate force. With the force you can make machines. With the machines you can save the humans the toil of sweat and the blood and the flesh, and you can make the machines, the tools, to the transportation. Like this poor train, designed by an ingenious human mind just to transport goods across the continent of the United States.